right, we're going to wrap up this lesson with the last few rules in exponential laws. Please make sure you're writing all these rules down because you will be using multiple rules in different problems as we get further into the lessons. All right, so let's go ahead and what I want you to do in your notebook, I want you to write the title as negative exponents, write the definition and the two examples, and go ahead and pause the video. All right, hopefully you got it written down. And when you write a negative exponent, so when you're simplifying, taking this as an example here, 7 to the negative second, that's a really small number on the number line. It's less than 1. So you can write this as a fraction. In this case, if you put a 1 over it, the 7 over 2 comes out positive. And this is the simplest form you can write a negative exponent. Looking at this one, 5 to the negative 3. If I write it as a fraction, I just put 1 over 5 to the third. You can even do this backwards. Go ahead and write this down. Try it backwards. 1 over 8 to the 12. Well, if this is written as positive 8 to the 12, what would it come out backwards? Negative 8 to the negative 12. So notice the exponent is on the bottom, therefore it's negative. Because this exponent right here is on the bottom, and you'll start seeing this when we get into the division rules, the quotient laws of exponent. You'll start seeing the exponent as a positive at the bottom, but it's truly a negative. So here, you can see this is positive, and here, you can see this converted as positive as well. Quotient rule of exponent. Please make sure you write that down. Quotient rule of exponent. Quotient is just like dividing. When you divide two exponents with the same base, you keep the base and you subtract the exponent. So remember, when we were multiplying, we added the exponents, but when we are dividing, we're going to subtract the exponents. It's almost like an inverse operation. What I want you to do is go ahead and write the rule and the exponent down and pause the video until you're done. All right, really quickly, just explain what you wrote down. If you have x to the fifth and x to the third, and then they're divided and you subtract, you're going to get x to the second. But since it's positive, it just stays as x to the second. You do not need to write it as a fraction with the negative law. Please make sure you write this in your notebook. Dividing fractions, when you subtract the exponent, the positive exponent goes on top, the negative exponent goes on the bottom, and you write it without the negative, just like we saw with the negative law. Don't forget, you write it at the bottom of a fraction because you're showing it's a small number using a fraction. If you're not done writing this in your notebook, please pause the video and go ahead and write this in your notebook. We're going to do a few examples, and what I want you to do is go ahead and write this down. We're going to do this one together. It should be in your notebook. Here, you will look at your numbers. Usually, if they're different, you can always multiply, divide. In this case, 2/3 cannot be simplified anymore, so 2/3 come out. But 7 over 5, well, I need to subtract 7 minus 5. And since it's positive, it goes on top. 2 to the x to the second over 3. Notice the exponent is positive when you subtract them, and it is written on the top. Here's the second example. Please write this in your notebook. I'll give you a second. Notice the number 4 over 7 cannot be reduced. It cannot be divided, so that will come out. But notice, 3 minus 9. If I do keep, flip, change, keep, flip, change, then I can see this is a positive and a negative number, which means I'm going to subtract and keep the sign of the larger number. This is going to make the exponent negative. Since the exponent is negative, it will go at the bottom. This will create -6. We're using the negative exponential law and the quotient law of exponents. We just did 2 and 1. Notice the exponent is written as a positive exponent on the bottom. The bottom represents negative exponential numbers. All right, what I want you to do is go ahead and write these examples down. After writing these examples down, what I want you to do is unpause the videos and we'll go over these examples. All right, welcome back. Let's look here. What I want you to notice here is in this example, notice that there are 3 terms in this type of problem. We have numerical terms, we have the variable of b, and the variable of n. So then what we're going to do is we're going to see if this could simplify. The 5 and the n cannot simplify, and the b and the n can. But notice this. The b is positive on the top and negative on the bottom. Since the number is higher at the bottom, the exponent is higher at the bottom, you know your b will stay at the bottom, and you'll do 1 minus 2, which if I do keep flip change, I can see the way better. In this case, my n, the exponent is higher on the top, so I know that it's going to be positive because it's on the top. And 6 minus 5 is 1, and 1 minus 2 is -1, but since we put it at the bottom, we can represent it that way. In this case here, again, we see numerical value and then 2 variables that we will be simplifying. This is an imaginary one. In this case, the 5 is larger at the bottom, so I know the y will be at the bottom, and I will be doing 1 minus 5. On the c, the exponent is larger on the top. 6 is larger than 2, so I know c will end up on the top, and we will subtract the exponents as 6 minus 2. When I simplify it, I'm going to get 3c to the 4th, because 6 minus 2 is 4. And then 1 minus 5 is -4, so it's represented at the bottom of the fraction. Okay? That is going to be at the end of the exponential laws that we will learn for today. Please practice using the slides and the exercise before the next lesson.